Welcome to the Explainer. So, if you've been working with AI coding agents lately, you've probably hit this incredibly frustrating wall. You know the one. Your agent writes this brilliant, complex application code locally, but the second you ask it to deploy that code to the cloud, it completely goes off the rails. It confidently hallucinates some multi-step workflow, skips absolutely vital permissions, or just completely crashes. Well, today we're looking at a pretty game-changing solution to this exact problem, the AWS Agent Toolkit. Okay, let's dive into this. Here's a quick roadmap of what we're covering today. We're going to look at the AI context gap, the core toolkit components, how agent skills actually work, a step-by-step Lambda deployment, how to scale this up for your engineering teams, and finally, getting it installed. All right, part one, the AI context gap and why these incredibly smart models keep failing at cloud deployments. I want you to think of your coding agent like a brilliant junior developer. They totally ace the interview, they know the theory backward and forward, but they haven't read a single company memo. They are completely uninformed about your specific current environment. The source material puts it perfectly. Your coding agent is smart, but AWS ships new services way faster than any model's static training data can keep up with. Without live guidance, they're inevitably going to skip a critical IAM permission or try to call an API that was deprecated like 6 months ago. The difference between the two approaches is honestly night and day. Relying on static training data just leads to rigid workflows, missing permissions, and outdated API calls. It's a mess. The real fix here is live AWS context. The Agent Toolkit basically closes that knowledge gap by wiring whatever coding agent you're already using directly into real-time, accurate documentation and fully tested playbooks. It turns what used to be a complete guessing game into this highly guided, fully auditable workflow.
Let's move to Section 2, the 4 core toolkit components. This is the architecture behind reliable agent actions.
So, how does this actually work under the hood? It's built on 4 main pillars. The AWS MCP server, agent skills, which basically act as your runbooks, IDE plugins, and your project-level rules files. Let's zoom in on the foundation of this whole setup. Okay, the AWS MCP server. This thing is the absolute heavy lifter of the whole operation. It's a managed endpoint using the Model Context Protocol. And what it does is give your coding agent the superpower to search actual current AWS documentation in real time. It's no longer just guessing based on 2-year-old training data. And even better, it lets the agent make authenticated AWS API calls right through your local IAM credentials. Everything funnels through this managed server and gets validated. Oh, and a really important side note here. The toolkit itself, completely free. You literally only pay for the actual AWS resources your agent ends up creating. Which brings us to Section 3, the anatomy of agent skills, how we replace massive docs with compact playbooks. Now, what's really interesting about this is how it handles context windows. If you've ever tried just copying and pasting a full AWS documentation page into a prompt, well, you know it eats up tens of thousands of tokens. It's totally overwhelming, completely unstructured, and the agent usually just loses the thread of what it's supposed to be doing halfway through. An agent skill fixes this. It's just a compact markdown file. We're talking maybe a few thousand tokens max. It gives step-by-step instructions written by a human engineer who knows exactly where AI agents usually trip up. The agent just hits the MCP server, finds the skill, loads it, follows the steps, and then drops it. It's super clean. All right, Section 4. Let's look at deploying Lambda step by step and actually trace the journey of a request. So you give the prompt, the agent searches its live context, grabs the right skill, and gets to work. And in a surprisingly fast 2 minutes and 35 seconds, it runs through these exact steps. It writes the code, zips it up, creates the IAM execution role, and, this is huge, it actually waits for IAM propagation. That is a step AIs almost always rush and fail on. Then it uploads the zip, spins up the Lambda function, creates the HTTP API, wires the integration, adds the permissions, and scopes down the routes. Boom. Done. I really want to focus on step 5 for a second. So the crucial point is this add permission step right here, because without this specific step, your API exists, your Lambda function exists, but they literally cannot talk to each other at all. When coding agents are just flying blind on their static training data, they miss this exact step almost every single time. But because our agent was following a targeted skill written by an expert, nailed it on the first try. But, this brings up a really fascinating question. Does the agent just mechanically read the skill and blindly follow it like a rigid script? Like, what happens if our prompt asks for something slightly different than what the runbook expects?
The answer is no, it doesn't just act like a robot following a script. And this is where it gets really cool. The toolkit provides the guardrails, but the agent still brings its own judgment to the table. For example, in our Lambda scenario, the agent actually noticed the loaded skill was originally written for older REST APIs. But because we explicitly asked for an HTTP API, which, by the way, is newer, simpler, and cheaper, it adapted the deployment on the fly. It even noticed that AWS created a broad catch-all route by default, and it intelligently went in and scoped that down to exactly what we wanted, just the get/hello route. That blend of human-provided structure and AI judgment is incredibly powerful.
Moving to Section 5, Scaling for Engineering Teams, because managing limits and ensuring security is a whole different ballgame.
All right, platform engineers, listen up. Because spinning up a Lambda on your personal laptop is awesome, but rolling this out to a team of 50 developers, that brings some real-world quotas you need to know about. I want you to burn this number into your mind, 27. The toolkit has a hard cap of exactly 27 concurrent connections per account per region. And as our source material notes, that limit is going to surprise a growing engineering team way faster than you think. And right behind it is your second critical number, 3. You are hard limited to 3 sustained requests per second. Now, if it's just you sitting at your desk, 3 requests a second is plenty. But if you have an entire dev team firing off automated agent requests all at the exact same time, yeah, you are going to slam into those rate limits fast. So how do we handle this without things breaking? Well, here are the best practices for rolling it out safely. Start your developers with read-only access. You can actually use specific IAM condition keys to block write operations that are initiated by an agent through the MCP server. Just let your teams get comfortable using the AI to search live docs and read skills first. You can always loosen the access later, but trying to claw back write access from developers once they have it? Good luck with that. And obviously, keep your eyes glued to those CloudWatch usage metrics. And for the security teams out there, you can breathe a sigh of relief here. The system gives you complete auditability. Every single API call the agent makes gets routed through the MCP server using that specific developer's IAM identity. Every parameter, every action, lands directly in AWS CloudTrail. You have a flawless, auditable record of exactly what the agent did and whose credentials it used. No mysteries. Finally, Section 6, Installing the Agent Toolkit and Getting Started in your IDE. And this brilliantly illustrates just how simple it is to get up and running. It literally takes about a minute. If you're using Claude Code or Code Catalyst, you just install the plugin right from your command line. Super easy. If you're on Cursor, Windsurf, or another client, you just manually add the AWS MCP server into your local MCP config file. The only prerequisite for either route is that you've got your AWS credentials configured on your machine, so standard AWS login or SSO. One quick architectural note to clear up before we wrap. Right now, the managed MCP server itself physically lives in the US East 1 and EU's Central 1 regions. But don't worry, that's just the endpoint your IDE communicates with. Your actual coding agent can still operate on and deploy resources to absolutely any AWS region globally. So we've seen exactly how the Agent Toolkit bridges that massive gap between an AI's static knowledge and the living, breathing reality of cloud architecture. By combining those focused agent skills with the live, real-time context of the MCP server, you are basically handing your AI the exact company memos it needs to do the job right. So I'll leave you with this. What are you going to deploy first, now that your coding agent actually has current docs and a proper skill to follow? Grab the toolkit, fire up your IDE, and let's find out. Thanks for joining this explainer.